You've cloned it, huh?
Yes.
So how have you saved it?
Pardon?
Have you unzipped it?
And no, I've just used the SSH URL. Then
Have
I've
you
used,
downloaded? You downloaded it.
yeah.
Unzip and then store it where you stored the other Rust
Project.
project.
Yes, I've
Then
done
from
it.
there, I'll take you through the procedure of installing it.
Okay.
Then from there, we now can proceed with our lesson.
Okay.
Mm. So this is the first language, zero knowledge proof language we're looking at. There are several others. After this, we'll be looking at NOR. That is another language. And of course, I've decided to begin with this one because once you understand this, then it will be easier for us to understand the rest, how, especially how to write zero knowledge proofs. Okay, can you see my screen? I don't know whether it has, because I'm seeing that it's not responding.
No, I can't.
You can't, eh?
Yeah.
It's not responding. I don't know why. Now, but if you've, have you saved it?
Yes, I've said it.
Now, just open. Let me unshare mine. Then because I want to see yours
Okay.
so that I can take you through the process of installing it. Then from there, we proceed with our lesson. Uh, so I'll not take you through the first examples I already looked at. I'll take you through another example so that people who are viewing, they don't view the same thing repeatedly. They can, when they look at yours, they see another example. But all the examples revolve about how to write the circuits using Circom. Are you able to share?
Let me share. Okay. Let me. Mm, I'm not able to share at the moment. Maybe I joined through the browser, but I've already started installing the Circom.
So how are you installing it?
Uh, I'm using the command there in the repo, in the repository. There is install, and then it has referred to installation section. I've clicked it, and in the installation section, I started with installing the dependency, then installing Circom. Because we have already cloned, I went ahead and did the second process of cargo build release, then cargo
Okay.
install path Circum.
Oh, well, all that information is in the repo.
Yes, yeah.
Oh,
In the yeah, in the report they have provided a link which you can
oh,
use.
so you've done cargo build release.
Currently, I'm in the cal cal. There is a for installing dependency. Currently, I'm there.
Cargo install path. Which command did you use?
Let me share in the chat.
Okay.
this command.
Or it's in a
Or
chart, eh? This one looks like, is it for installing Rust? This one is for installing Rust. I can
so
say, eh?
yeah, it's for
Installing Rust, but you already have Rust.
yeah, yeah.
Yeah, so you don't need to install Rust because you already have it.
Okay.
Mm. Now, so
Well,
my question was, you did cargo build release.
let
Has
me
it stopped? Has it run completion?
it's currently running. So
The cargo build release.
yes.
Okay. So after
And
that,
okay.
you will do cargo install, then dash dash path Circom. You said you are unable to share.
It's giving me an error. Cannot share screen, cannot start screen share. Choose one of the option.
Oh,
Install,
okay.
yeah, install some dependency or switch to Excel display server. And currently I don't know what are those.
Oh, why is that? Are you using a phone or a laptop?
A laptop.
And you say when you click share, it does not share your screen.
Yeah, but I can join using the browser. Then I try
How have you joined? You joined using what?
using uh using Zoom application, which was installed in my laptop.
Okay, so I don't know why, because even that one is supposed to share. I don't understand. Because I needed to see what we are doing so that I can direct where possible as I look at your results as we run together.
Okay, I think let me try joining using the browser. Just in a moment.
So let's continue. As today we wanted to look at the non-quadratic constraints in among other topics in Circom. So the first topic here, I want to show you which constraints, as we had already discussed the rank 1 constraint system. I want to show which constraints will not run. So if it is not in the format of the rank 1 constraint system, then if you write a Circom circuit, then it will not, that one will not run. So for it to run, it must be in a rank 1 constraint system format. So this format, we said, for it to be in rank 1 constraint system, then every equation, and that's what I've noted here, that each row or every equation should have only one multiplication. Yes, you can now, should I give you a chance to share? Ken? Ken, do you think you can share? So what I said that the equation or a row should have only one multiplication. So every time that it will have more than one multiplication, that circuit will not compile. So like Z is A times B times C. If you write this as it is, it will not compile. So what we said last time, that then we must have intermediate values. For instance, you can say let V1 be A times B, so that, and you can see this is only one multiplication here, and then Z will then be V1 times C, and again, another one multiplication. So these are now two equations. We had this, but now we can achieve it. We can arrive at this by bringing in an intermediate value, so that now our final equation becomes this. And the thing is, every time you are doing this, there must be only one multiplication at a time. So every time that if you are to use more than one multiplication, then that circuit will not compile. So that is what I mean by non-quadratic constraints. So what it means is that a circuit or constraints must be quadratic, not non-quadratic. They should be quadratic. So to be quadratic, it means they must satisfy the rank 1 constraint system. In other words, there must be only one multiplication in each equation. Now, so before I proceed, Ken, you cannot hear me. Or is it me that is not hearing you? Because I cannot hear you. You are muted, or should I unmute you?
Oh, I can hear it.
Are you able to share your screen now? Should I unshare mine so that you share? Because when I begin doing this example, I want to explain to you so that you understand the previous examples that I did while you are not around.
Okay, no, I can. You can try. You can try to. I can try to share it once more.
Okay, try. Let's see.
It's sharing. Yeah. Okay. So currently, I've, I've used
Or is
I've,
it's
I've
still compiling, huh?
build and yes.
No, just share your need, just share your code. That's what I want us to look at.
Okay.
You're sharing more than two things. You're sharing your code, and at the same time, you're sharing the website.
Okay. Uh, so I've used this command uh, for cargo build, and it has built. Yeah, it has indicated finished, and then I use the cargo install, and currently it's building.
Okay, okay, okay. Yeah, that one takes some few minutes, about 3 to 5 minutes. I think it's
Okay.
just about. We can give it a few, just like 1 or 2 minutes. I think it should be done. It takes, although last time some of those who are installing last time, they said it took a bit some time because of they were using internet. They said because of using internet, since the internet was already engaged. But I can see it's 152 out of 172, which means it's not far from finishing.
Oh,
Oh, it's 163 now out of 172.
yes.
Okay. But now, I hope the earlier lessons that we did on rank one constraint system, you were present, huh? I used to see you.
I was going through the videos actually.
Or you did not attend the classes.
Yeah, but for
Okay.
rank one I did, but the one which I didn't understood, I used to go back to the video.
I'm not seeing your code. What I'm seeing is something different. You are saying something.
I was saying for the one that I didn't understood, I went back to the video to for reference.
Okay.
Yeah.
Yeah, because what we'll be doing when you're writing this Circom, basically
Okay.
what you're doing is just what we did. We use the knowledge of the rank one constraint system that we did. So when you're writing those circuits and constraints, must be in
Okay.
that format. So what is that you are typing?
Uh, I've I've opened now on VS Code. So
What?
it I've, I've open now on VS Code, but it has installed
Yeah,
cargo install.
For you to know if it has installed, you can write cargo help, so that we see cargo, and then there's a dash and then help, so that we see what it has been, if it has installed.
Okay, I didn't hear you.
I said for you to tell if it has installed properly on your, why is your name changing every time? Where's your terminal? I think your internet is not okay. It's not allowing you to share. Is that okay? And I can't even hear you. Now, so what I had said earlier, I had said whenever we are writing Circom, we must ensure that our equations have one multiplication. Our constraints have one multiplication at a time. So, for instance, looking at this circuit, you can say there is input A, there's input B, there's input C, and now the output is a product of these three. So you can see the three are being multiplied together. So this one, if we run it, it will not compile. We must ensure that what we need for it to compile, we don't need this. What we need is we need to introduce another signal, call it S1 or V1, which is supposed to be gotten by, so S1 is supposed to be a product of A and B, for instance, A and B. And then we come at a point where now we have the out. You have the out. The out should be a product of S1 and C. So if you do this, then it will now run. But if you write it the way it was, it will not run. But let's just try. Let's write it. Since we are learning how to write, let's just write this and see what it happens. What will then happen? Ken, are you back? You're not yet back. Now, so I'll share my code. And just take you through the steps of how to write that. Okay, I've already written it in my code. I've already written it as a multiplication, multiply, invalid. Now, what we normally do, if I want to write, I would come here at Circom here. Just a minute, let me do this. I would come to this Circom. You can see, when you look at my terminal, I'm already in Circom. When you look at my terminal, I'm already in Circom, but what I just want here with the name that I want to call my my code. So new, I press this new, then it gives me an opportunity to write a new file. Now, Ken, you're back. Hello? Now, so let me just create another file. Although I already had this file, but let me just create another file. So let me go through again the step. I said I would click here and say new. So I want to call it, how should I call it? I want to call it invalid. Invalid multiply. Invalid multiply .com. So I want to call it, no, not .circom. .circom. So I want to call it that, invalid multiply .circom. So if I click it, it gives me a place to enter my code. So let me see if I can get, I can copy this code and just paste it there to save on time. So I want to enter my code. Invalid. Call it, so that is my code. Ken, can you see what I'm doing?
Yes, I can see it.
Or you can see, huh?
Yes.
Now I'm showing how to write a code. So you've seen how I've created a file. I came to this Circom. You see where
Okay.
I'm pointing, is that okay?
Yeah.
And then I just right-clicked and then say the new file. Then I gave my new file the name invalid multiply.circom.
Okay.
Now this is the invalid one. So I've called it invalid because I'm not expecting it to run, because
Okay.
I can see that this constraint has two multiplication like this multiplication and this multiplication. And as we said, for the constraint to be valid, there must be only one multiplication at a time. So the moment you have three multiplications or two multiplications in the same equation, that circuit will not compile. So that is why I'm calling it invalid. And I just want to see whether it will compile. So after creating these, writing your code, what follows is to run. What follows is to run the code and want to see whether it will run. So for me to run it, I would come to, let me refresh my terminal. I'm at the terminal. You can see my terminal, is that okay?
Yes, I can see it.
So the way I've saved it at a Circom dash master. That is how it appears. That's how I've saved it. But now for me to run this code that I've just created, I would cd Circom. I would cd Circom. Then I come and I run by the command that I want to use to run is Circom. Oh, it's supposed to be Circom. My file is invalid multiply.circom. So I just say Circom then invalid multiply dot Circom. So this is the command I use. And when I use that command, it gives me an error. And the error is it's saying that the constraint is non-quadratic. And therefore, non-quadratic constraints are not allowed. That is what it's telling me. It's telling me that there is a problem here. That this, what I've written here is not allowed. There is supposed to be only one multiplication at a time. So that is what it's telling me, that what I've written here is not correct. Now, so for me to rectify that, as I had already said, I needed to come up with the intermediate values. Need to come up with the intermediate values so that I want to call A times B S1. Want to call A times B S1 so that finally I have the output as a product of S1 times C. So that is what I want to do. So I've now brought in another signal. I brought in another signal. Of course, okay, I just remind you, we use signal input, where input is, you then say what the input is A in our case. The values you are inputting. Then the other value you're inputting is B, the other value you're inputting is C. Now I brought in another signal, but this one is not an input. It's just signal S1. And this signal S1, I've defined it as a product of A and B. And then we have signal output. I've called it out. You can, if you want, you can call it Z. You can say signal output Z if you want. But now I've defined this out as a product of S1 and C. I've defined as a product of S1 and C. Now this one, if I run it, it should now run because our constraints are now quadratic. They have one multiplication. Like you can see, this one has one multiplication only, and this one has only one multiplication. So let me now run it and see if it will run. Just want to run it down here. I'm still inside Circom. You can see I'm still inside Circom. So I just want to write here. Let me just copy the command I had used. I had used the command Circom invalid multiply dot Circom. So I'm just copying this. Then I paste it here and now run this time. It has run and it has told me that template instance 1, everything went okay. So when you do that, it means the circuit that you've written is okay. It has run. Now, so that's the first step. The first step you do, you must write a circuit that is okay so that it runs. Then after that, you need to generate, R1 CS, that is rank 1 constraint system parameters. So that is what I want to generate. So for us to generate that, I'm still inside Circom. I'll use the command Circom. No, it's not multiply. It's supposed to be the name of our code. The name of our code is invalid. So it's supposed to be, let me just write it here properly. Then I copy and the name of my code is, my file is invalid multiply. Let me just put it here. So this is what I want to copy and paste it here. So it's the command has to begin with the Circom, then invalid multiply dot Circom. So you can see dash R1CS to generate the rank 1 constraint system, and then the symbols, generated the symbols. Now, so when I do that, does it say found an argument sim, which wasn't expected? There are supposed to be dash dash, not just one dash. It's supposed to be dash dash. I think that is the error. So let me again put it. What is this error? Found an argument which wasn't expected. Just a minute. I don't know why it's giving this error. Yes, Ken, my internet has some issues. Now, so I was looking at why this was not running. Let me again try it. It's now okay. It's now okay. I don't know why it was not running actually. And why is it now running? Because I just put, you can see, is that okay?
Yes, I can see.
Yeah, this is the command Circom invalid multiply dot Circom. So it has generated the rank 1 constraint system values, and has also mapped the symbols, the appropriate symbols. Now it's telling me when you look down here on what has been generated, is that the template instances are 1, non-linear constraints are 2, linear constraints are 0, and so on. So that's what it's supposed to tell you. The labels and the wires, the labels are 6. Okay, so those are what it's supposed to generate. Now, after you've generated the rank 1 constraint system values, you may want to see what they are. You may want to see what they are. So for you to see what they are, you run the command snack.js rank 1 constraint system print. Let me just write it here. Just write it here. This is the code. This is the command I want to use. Snack.js rank 1 constraint system print multiply dot rank 1 constraint system. So let me just use that. Now it says there's something here. Okay, let me again do it. Let me go back to cd Circom, and just go back and repeat that code, repeat that command. Now the command was this. This was the command. I only need to change this part, because this part mine is supposed to be invalid. That's how I call it, but the one we are now using is valid. But that's how I called my file, invalid multiply. Invalid multiply, yes, that is the name. So this is the code, that's the code I want to use. No, that is the command. So snack.js r1cs print invalid multiply rank 1 constraint. There's an error. I think I've used a wrong command. I've used invalid. It's not supposed to be invalid because I'm using this multiply. I think this multiply is the one that I'm supposed to be using. Let me just again see. Yes. Now, so when you look at what has been generated, I don't know why this thing wants to, every time I input a command, it does not respond on the first instance. It has to respond on a second instance. I don't know why it's doing that. It's not responding in the first instance, it has to respond on the second instance. It has to respond in the second instance. I don't know why it's doing that. Now, so the same command with invalid it has run. But now this is what I wanted. This is what I wanted. Look at this number that has been generated here. It ends with the 6, begins with the 211. Now, I had already explained this earlier. This thing is calculated using a prime number P, and the prime number P equals to what you are seeing here. What you are seeing here, the only difference is that P has a 7 at the end. So this calculation has been done mod P, where P ends with a 7. And the number that we have, let me call it N. So what I was saying, if you have something like 8 mod 9, you're subtracting 9 from 8, and you get -1. So the number that we have, subtract P from that number, you get -1. Now, so what are we seeing therefore? Let's go back to our timeline. What we are saying is this -1, I've said this number is like -1, main dot A. So this is what I'm seeing. -1 dot A dot A. Then there's a multiplication here, dot B. There's a multiplication. When you take S1 the other side of the equal sign, what we began with. That's what we began with. That is what we have here. So this is what has been written now in rank 1 constraint system format. So this equation here, this constraint is this, what you are seeing here, beginning with the negative or 221.8, and then it ends with equals to 0. So once you understand that, it becomes very easy that the whole of this number is just -1. Then this other number is just -1. See, when I do it algebraically, I come back to what I began with. What about this other one? This other one is -1 multiplied by S1. -1 multiplied by S1, this S1, then times C, then minus, there's this minus, then there's this -1 multiplied by out is equals to 0. So when you do arithmetically, algebraically, this is what you get. This is what you get. So let me just show you. What I have is -1 S1 multiplied by C, then minus -1 multiplied by out equals to 0. So this will be S1, -S1 times C, then plus out. You take out the other side of the equal sign, this will be minus out. And this will be S1 times C. So when you divide by minus both sides, you end up with the S1 C is out. So again, I just mean that the whole of this thing you're seeing here is just this. That's what it means. So we've just converted our signals, our arithmetic, our circuit to rank 1 constraint format. So that is what it does, what we have done. So if you convert, is the conversion. That's how it converts. Now, so after converting this, what you need to do is to create a witness. Need to create a witness. Of course, when you are doing these zero knowledge proofs, we are very much interested with the witness because we want the prover has claimed to know Z, for instance. In our case, I'm referring to this case. We have somebody who has claimed to know what Z is, what out is this out. Now, this is what it was. We began with this. The out was equal to A times B times C. Let me call it even Z instead of out. So somebody claims to know what Z is. So for this person to claim what Z is, let me assume you are the verifier and I'm the prover. So I have claimed to know what Z is. So you want me to prove that I know what Z is? What I'll do, therefore, I'll give you some witness. I'll give you witness. I'll give you, without revealing what Z is, without revealing what A is, without revealing what B is, without revealing what C is, I'll give you witness. What I mean by witness, I mean that I'll give you some value A, I'll give you some value B, I'll give you some value C, and I'll give you some value Z, and I'll give you some intermediate value S1, imaginary. So it's you who will now be confirming whether the values I've given you fulfill the equation. For me, I just claim I know what Z is. So I give you random values. So those random values, I'm calling them witness. So what we want to do this time, create a witness. And then, of course, when you're writing zero knowledge proofs, that's what we'll be doing. We want to create a witness at every point so that the person who was, if you're claiming, then you have to give witness of what you're claiming. Now, so the command that will assist me to give a witness is the command Circom multiply.circom. This one, ours is not multiply, ours is invalid. Our file is called invalid multiply. So this command will assist us to come up with a witness. So I just put that command. I hope this time it's going to run the first instance. Again, it has not run the first instance. I don't know why every time we do it, it has to reject our first, then accept it later. But that is a command. Let me again do it. Again do it because we've already done the command to the command that we did was to give this around. So we need just to give it this command. It's supposed to give us. It's still giving me. Okay, it's no problem. Let me just refresh. Let me refresh the terminal, then again do it. The Circom, let me go back. Then Circom invalid. No. My invalid is not correctly written. My invalid is not correctly written. I think that is where the problem is. Invalid. It has to agree with what you have, because this is what we have here. Invalid. The name of the file, it has to be correctly written. So that is where we're getting the problem. I think that is why I've been getting all these problems. Sorry. Definition, spelling of invalid. Okay, let me just run this. So when you run it, it gives you this. But what is important to me is not even what it has given me. What is important is, let me come back on the left side, check on the left side. This is the name of the, this is the name of, this is the name of our file. Let me just again check this. That is the name of the file. And then you can see some new things have been generated. There is rank 1 constant system has been generated. We have this. We don't need this. Ours, there are so many folders here. There are so many files, but ours is called invalid. But now what is important, what I'm looking at is this invalid. You can see where I'm pointing, yeah? Invalid multiply slash, hyphen JS. You're seeing it?
Yes, I can see
Yeah, that
it.
is the one. You can see it, eh? Yeah, that is the one that we want. So we'll go inside there and then create a file for inserting our witness. We'll go inside there and then insert a file. In fact, and we shall put a new file. But before that, let me come back to the terminal. Our terminal, you can see I'm inside Circom. I'm inside this file. I want to go inside that file, so I'll cd invalid. I want to ensure that this time the spelling is correct. Invalid multiply. There is underscore JS, then slash. Let's put that, and then enter. So we are now inside there. Okay, so we'll now be working from there. Now let's create a file here. Inside that, invalid, and then I wanted to call it input the name input is valid as, oh, it's valid. No, it's not valid as a file. What is that? Okay, let me click. Is click there and then create a new file. Why is it saying that is invalid? So maybe it's because I've used this name several times. Let me call it output so that I don't forget what output.json. Now, so it has given me a place to enter my witness. A place to enter my witness. So I now want to enter my witness there. You only put the value of A, B, and C, but the other values that we had, the intermediate value and output would be computed by the code that it will compute it. So I've now input my witness. I've said let A be, you can see A is inside those opening and closing marks, quotation marks. And then there is this colon, then the value of A. I want A to be 3, then comma, and then I want B to be 5, then comma, I want C to be 7. So you can change these values to another values if you then want 4. Supposing you want this one even to be 6, there's no problem. But this now is your witness. I've called it output.json. I think it must have refused because I've used input several times. It's here, and I've used it elsewhere else also. After inserting your input, your witness, you now want to generate that witness. You want to generate that witness. Because we're just inputting, but now when you're writing your zero knowledge book, generate itself. So how does it generate? For us to generate it, I'll use this code. I'll use not code. I'll use this command. I'll only change here. I'll only change here. Ours is called invalid. I'll use this command. This is the one I want us to use to generate our witness. So I put in the timeline and enter. It says, again, it has given us an error. Now, after giving us an error, it says that we should call it input.json. And when we put that input, it tells us that it's not correct. Let's change it. Let's change the name. Let's rename it. And I hope this time they'll accept it. Okay. Now, so let's again run it. So I again run this code, this command. Yes, it has accepted. It has accepted. I don't know why this thing has to reject at some point and then accepts after some struggle. Now, so it has accepted using the same code, command node generate witness. I want to generate witness.js. The name of the file is invalid multiply, then was.wasm, then input. Oh, yeah. So it refused to run when we used output because we did not change this command here. We should have put output.json. So I changed the invalid and I forgot to change the input. So it will have accepted even the output. Only that I did not use output. I used input at this point. So that is where the problem was. Now, so the witness has been generated, but you cannot see it. If you check here, you can see there is a witness. Witness has been generated. But when you click on it, the file cannot open. So it has been written as binary. You cannot see it. But there's no problem. So for us to see it is not a problem. It's very easy for us. I'll use this command snags.js witness export JSON witness dot w something WTS, the short form of witness. So this is the command I'll use, and then it has run. Let me see whether there's an error again. No, there's no error. There's no error. It has run. But now, for you to see it, you must say cat witness.json. Cat witness.json. So that's a command you should now use. So let me just write it here. Cat witness.json. Now, when you run it, it gives you the witness. This is now witness. It gives you a witness. Yeah, witness, when you are writing rank 1 constant system, we said we would always begin with 1, then the output. The output, when you multiply these things, 4 times 5 times 6, you get 120. That is the output. C, A times B times C. So A times B, if A is 4 and B is 5 and C is 6, then that product is 120. So that's what it has given us. And then this is A, and this is B, and this is C, and then the intermediate value, A times B. A times B, the intermediate value is here. Now, so this is our witness. So that is what we did while you were away, only that we used a different example. At this time, we used another example. But the good thing with this example, we began by looking at how not to write the constraint, how not to write. If you write it with the very many multiplications inside, it will not run. We tried that, and when we compiled, it gave us an error. But then when we corrected, you can see that it's now running, and we've gone up to the point of generating a witness. Now, so what follows next? In the next lesson, I'll now show how to generate a proof and verify that proof. So for what we've just done, for the circuit that we wrote, we can generate, our circuit was here. Here it is. For this one, we can still generate proof and verify that proof. So that is what we'll be looking at next time. Any question? Ken?
Yes. Actually, I've been able to run the command. I've created a
Just
file.
Just share.
And it won't be able to share.
Oh, okay, okay.
But what can I share? Okay. Actually, my question was, when a person runs the snack.js r1 print multiply dot r1 cs rank1 cs, you're being given the Circom, not that command. When you run the Circom multiply.com.circum, then dash dash r1 cs, then dash dash cym, and dash dash wasm. Those three files which now you're being given, can one be able to, what are the need for those three files?
Okay. Now, at your code, you
Yes.
still have your code. Is that okay?
Yes.
Now, your code just run for me a Circom help. Circom dash help.
Yeah, it has given me.
What does it give you?
Circum compiler dot
There are flags. Are there flags somewhere?
yeah, the flags, the options, and the argument.
Flags, huh?
Yeah.
And then on the right, the description.
Oh yeah.
Can you see dash dash R1 CS?
Yes.
On the right, what does it say that one does?
Outputs the constraints in
Yes.
R1 CS
Yes.
format.
So when you say dash dash R1 CS, that is what it does. It outputs the constraints.
Okay.
What about dash dash SYM? What does it say it does?
Outputs the output witness in system format.
Yes. The outputs witness in
SYM format.
yes. What about WASM?
Compiles the circuit to WASM.
Yes. So when you go through those flags, all of them are there. So they are supposed to guide you every time you are doing it. So when you want something, you know what to go for. So if you want
Okay.
to output constraints, circuits in constant form, you have dash dash R CS R1 CS and so on. So all those flags are there. Is that okay?
Okay.
Now,
Yes.
again, there's something else I want you to do for me so that again, it will also help you. We've just done
Okay.
circuit help. We've done Circom help. Is that okay?
Yes.
Circom help has given us that. Now, so
Yes.
what about just a snack JS help? What about snack JS? Then dash help.
It has given me a lot. Snap.js.
Can
Okay.
you see something called growth 16 towards the bottom?
Growth 16 setup. Growth
Yes.
16.
So what is there? What it has given you are the snacks.
Okay.
All the snacks and their role.
Okay.
Yes, what they're doing. So they are already installed. All the snacks are already installed, and that is what
Yes.
on the right side you can see the description, what they'll be helping us with.
Yes.
Yes.
Then,
Yeah, so but you remember the Circom.help, it will help you to know the flags that you require at every point when you're writing a command to run, what do you want to get? So you go to those flags and you see what you want to get and use that command.
okay.
Yes. Okay, so I can see you the host, so you can end the meeting for everyone because you're the host, yes.
Do tomorrow.
Yeah.